Welcome back. This is Mrs. Rewrite with Advanced Geometry. Today's lesson is 2.5, Reason Using Properties of Algebra. You should have already copied the four-year notebooks on page 97, 98, and 99 during your warm-up time. So we're just going to get right into this. So we are going to write reasons for each step. So we're going to solve the equation, the multi-step equation, 2x plus 5 equals 20 minus 3x. And we're going to write a reason for each step. So basically we're getting into writing proofs, but this one is an algebraic proof, and we're just kind of starting to show how we would write a proof. So the first thing we do is we write down the equation, and that would be given because they gave it to us. Make sense? The next thing, going from here to here, what did they do? They added 3x to each side, right? So when you're adding the same thing to both sides, that's called the addition property of equality. Property of equality means that we're doing it to both sides. So going from here to here, what did you do? You just combined like terms, right? Which we call simplify. From here to here, what'd they do? They subtracted 5 from both sides. What do you think that's called? Subtraction property of equality, not so hard. And then from here to here, they divide by 5 on both sides, which is the division property of equality because they did it to both sides. They kept it balanced. So basically what we're kind of trying to foreshadow is what we're about to get into, which is where we are going to end up doing t-tables. So it'll look like this, and this will say statements, or statement, and reason. And so this is actually a proof right here. This would be a 2-column proof. So you'd have like your first line was given, your second line, and your reason. And this is a 2-column proof. So I just kind of turned this into a 2-column proof just by putting that little t-table. And that's what we're going to start getting into. So, solve -4 times 11x plus 2 equals 80. Write a reason for each step. So with this one, I need to pick a better color. What was I doing? There, I want to pick a color. All right, so we have our statements and our reasons. So we're going to start with -4 times 11x plus 2 equals 80. What do I put for my reason? Given. We always start with given. If I was going to solve this, what's the next thing I would do? Distribute. So I'd have -44x minus 8 equals 80. And you said that was the distributive property. Is it a property of equality? No, because we're not doing the same thing to both sides. All right, what's next? Subtract 8 from both sides? Add 8, because -8 plus 8 is 0. It cancels out. So I would be left with -44x equals 88. And how we got that was we added to both sides. So that would be the addition property of equality. And so for property of equality, you can write out property of equality, or you can put P.O.E. for property of equality. You can just shorten it like that. Step 4. Going from here to what? What do I need to do next? I divide by -44 on both sides, right? Leaving me with x equals -2. And what we did was division on both sides. So the division property of equality. And we're done. That is a 2-column proof. Pretty simple, right? So this is simple, and it's simple because this is an algebraic proof. So it's dealing with algebra, which you're already comfortable and familiar with. The ones that you probably won't love are geometric proofs because they deal with geometry and postulates, theorems, corollaries. They're just so fun. when you exercise, your target heart rate should be between 50% and 70% of your maximum heart rate. Your target heart rate, R, at 70% can be determined by the formula R equals 0.70 times 220 minus A, where A represents your age in years. Solve the formula for A. So if I needed to solve this formula for A, what am I going to do? R equals 0.70, 220 minus A. I need A by itself, so let's go, we could divide that out. You have two options. Actually, I think it's smarter probably just to divide from the start, right? Divide by 0.7 on both sides. So then we would have 220 minus A equals R divided by 0.7 or 0.70. And then I'm not going to add A to both sides. I'm going to subtract 220. And I would have negative A equals R over 0.70 minus 220. To get rid of that negative, I can just change everybody's signs. So A equals negative R over 0.70 plus 220. And now I solved for A. Okay, so they're showing you. They're actually doing the proof because they're fun. All right, so on this next one, we're going to write the reasons. So let's just do a nice 2-column proof. So we have our statements and our reasons. So number 1, 4x plus 9 equals negative 3x plus 2, given. All right, what do I do first? If I was solving this, what would I do first? Subtract what? What? I'd get the x's together, so I'd add 3x to both sides. So I'd have 7x plus 9 equals 2. And that was addition property of equality. Now what? Subtract 2? I want x by itself. Subtract 9. 7x equals negative 7, subtraction property of equality. Now what? Divide by 7 on both sides. X equals negative 1, division property of equality. And we're done. And we could always plug back in to double check that we didn't mess anything up. 4 times negative 1 is negative 4. Negative 4 plus 9 is 5. You'd have 3 plus 2 is 5. 5 equals 5, so we know we didn't mess anything up. And we have another one. How about you guys try this one on your own? So you have your statements and you have your reasons. I want you guys to try and get this one started and see if you can get the same thing as me. So pause the video. So our first step is to write the problem and state given. Right, our reason is given. Number 2. I would distribute, right, distributive property. So 14x plus 21 minus 3x equals negative 1. And that is the distributive property. Now I would combine like terms. 11x plus 21 equals negative 1. I combined this and this, and they're on the same side, so it's just simplify. Now I would subtract 21 from both sides. 11x equals negative 22, and that's the subtraction property of equality. Now I have to divide by 11 on both sides. And that is the division property of equality. Do you guys get the same thing? Awesome. Good job. Solve the formula. The area equals 1/2 base times height for B. So we could do this as a proof as well. We can have our statements and our reasons. A equals 1/2 BH given. We're solving for B. So multiply by 2 on both sides. 2A equals BH. Multiplication. Property of equality. Divide by H on both sides. 2A over H equals B. And that would be the division property of equality. And then you can flip-flop it. And you can say B equals 2A over H because it just looks more normal to start with the B. And when you flip-flop it, that's like if A equals B, then B equals A. That is that transitive or symmetric? Reflexive. It's reflexive. Sorry, I'm like going through all the properties in my head. That is the reflexive property. Reflexive property. You can flip-flop it. Make sense? Let's see how they did it. They wrote it. They multiplied by 2 on both sides. They divided by H on both sides. And then they just left it like that. They didn't do the reflexive to flip it to make it look more normal, but you totally can. All right, so now this is where you guys are not going to like it, because this one is a geometric proof. So, you are designing a logo to sell daffodils. Use the given information. Determine whether the measure of angle EBA is equal to DBC. So we're basically trying to see, is this equal to this? Do you guys see that? So what do? We start with what's given. So when we do our little t-table, right? We do our t-table. And what's given? Angle 1 is congruent to angle 3, right? The measure of angle 1 is congruent to angle 3 given. Why? It has tick marks saying, hey, dude, I'm equal. What else do we know? We know that angle 1 plus angle 2 equals this whole angle, correct? Angle CBD is angle 1 plus angle 2. Angle addition postulate. Part plus part equals whole. What else do we know? We know that this angle right here, angle EBA, is angle 2 plus angle 3. Angle addition postulate, right? Well, if one of them is 1 plus 2 and one of them is 3 plus 2, and I need one of these sides to like be the same, right? So like, okay, let me like step back. Let me put something here. Okay. So let me just like write this out so it makes sense. So this is step 1. So step 2 would be the measure of angle CBD. Actually, I'm going to write it in the same order that they wrote it. So the measure of angle DBC equals the measure of angle DBC, 1 and 2. And that is angle addition postulate. Remember the segment addition postulate and the angle addition postulate? Those are what we're using. Now I'm going to do this one. the measure of angle EBA equals the measure of angle EBA, 2 and 3. So because this one had 2 here, I decided to put 3 too, okay? So I need these both to look the same, and this is also angle addition postulate. I need these both to look exactly the same so that I can set these equal to each other instead, because I can just like substitute a whole side for a whole side. So for these to look the same, look over here, guys. Do you guys see how angle 1 and 3 are the same? So can't I switch this 3? Can't I switch this 3 out for a 1 because they're equal? So I could just go and say the measure of angle EBA equals the measure of angle 1 plus the measure of angle 2. And I was able to do that by substitution. I'm subbing that 3 out for a 1 because they're equal. I'm using substitution. So now that this and this are identical, I can sub this in here, right? Or sub this in here. So I'd have the measure of angle EBA equals the measure of angle DBC. And I'm able to do this because right here and right here are the same. So I can sub this in here. When you're substituting a whole side for a whole side, we call that transitive property. When you're subbing a whole side for a whole side, it's a transitive property. And now we got to what we wanted to solve. This is what they wanted. Does that make sense? Well, think about it, guys. If these are both the same and this is the same on both of them, this overlaps. Obviously, they're both going to be equal, but this is the proof as to why. We have to prove that they're equal. So, we can also do the segment addition postulate. So on this one, we have our statements, we have our reasons. All right, so it says AB equals CD. AB equals CD. So we're going to start with AB equals CD given. What we're trying to prove is this. So this is going to be all the way at the bottom. This is what we're trying to prove. So we need to get there. We're trying to prove that AC is equal to BD. So it's the same thing as those angles, but now it's a segment. So what do we know? We know that AB equals, or not AB, sorry, AC. AC equals AB plus BC, right? And we know that BD equals let's line them up, BC plus CD. And how do we know those? Segment addition postulate. Segment addition postulate. All right, so we want these once again to be exactly the same. What about these two? Can't we sub one for the other? So why don't I sub AC? I can turn into a AB, right? I'm going to take this one and I'm going to switch this up. I'm going to change this AB up. So I'm going to say AC equals CD plus BC. I'm plugging this in here, right? Because I can. And that would be substitution because I'm subbing part of a side. Do you see how these are now exactly the same? So now you can go straight to what they want you to prove. AC equals BD, transitive property. So transitive property is like substitution, but it's when substitution is a whole side for a whole side. Make sense? You can see how they did it. So they added them, and then they did the substitution. They're calling it substitution. What did they do? They did addition, property of equality. Segment addition, segment addition. And then they said substitution, but they shouldn't have said substitution because they're subbing a whole side for a whole side. It's transitive. They're mixing up their properties. Name the property of equality the statement illustrates. Okay, so if the measure of angle 6 equals the measure of angle 7, then the measure of angle 7 equals the measure of angle 6. So this is like if A equals B, then B equals A. Which property is that you copied down for your warm-up? When you can flip-flop it. We used this one earlier in this lesson. Remember when I put B, when we were solving for B, and I wanted it on the left side instead of the right side, and I just flip-flopped it, and I called it what? No. Reflexive. If B equals A, then A equals B. You guys said it was reflexive. That's symmetric. I thought it was symmetric. But you guys shouted out reflexive. It's symmetric. If A equals B, then B equals A. Symmetric. All right, if JK equals KL and KL equals 12, then JK equals 12. So this one's cutting out your middleman, right? Cutting out that overlap. If A equals B and B equals C, then A equals C. When we cut out the middleman, that is the transitive property. If A equals B and B equals C, then A equals C. Right? We're subbing a whole side for a whole side. We're subbing in this 12 for a whole side. Sub a whole side for a whole side. Transitive. The measure of angle W equals the measure of angle W. The same thing equaling the same thing. That's reflexive. That is reflexive. So going back to that proof that we did, instead change that from reflexive to symmetric. Right? Because symmetric is when you flip-flop. Not reflexive. Reflexive is same thing equaling same thing. I listened to you guys. I shouldn't do that. It's been a while since we've been using these properties, so, I'm more gullible. All right, guys, that is everything on your lesson 2.5, Reason Using Properties of Algebra. We hope you enjoyed the lesson. Have a great day. Like and subscribe.